Hey guys, it's Vince. Today in this video we're going to be discussing a Gerber Sabre 408 retrofit. Now, I haven't done many videos as extensive as this video will be covering a retrofit, but I feel there's a lot to learn here, especially to guys purchasing older equipment or for guys that naturally do have these older Sabre systems. I've done quite a few retrofits on the Gerber Sabre models, but I want to cover in detail through these excellent pictures that I received from a client I'm working on right now doing a retrofit for, and I want to cover some of the details that are involved with a retrofit of this caliber, because a lot of times, once again, I've discussed it many times before, there are so many variables involved with building a system based on what this particular client or you for say requires. So covering this in a video is really the only way to do it. So you can see he was nice enough to label here current spindle VFD, and this client, just so everybody knows, international. They're actually in Denmark. So going over this is something that, once again, is imperative to see with your own eyes, because as we cover in detail what needs to be done, it all starts making sense, I feel, a lot more than just reading something or when I get a blatant, just arbitrary email requesting a retrofit. So what we've got here is the first current spindle VFD, and you'll see why he wrote this here. But again, we have an IDM P5 series. It turns out from the client, this is a Yasukawa drive. Again, I have no information on this, and I get this question all the time. I want such and such features that I had on my old system. What can you implement from the old system naturally to the new system? This is a great question. The answer is it all depends on how much you know about your old system. Let me explain. If you have all the literature required and the understanding required to run what you're asking me to develop for you, then you're going to be fine. And when I say that, I get a lot of guys like this particular client that'll say, hey, I want to have PWM control in my spindle just like I do in my old software. Well, here's the thing. You're using a non-proprietary VFD. You're using a VFD that's older. You need to have the VFD's user's manual. You need to understand the VFD's user's manual to connect the PWM signals for speed manipulation on the new controller, or else we're SOL when we try to connect everything. Because here's the thing, I can build the controller to suit whatever you ask, but if you don't understand how to hook the components up to get the features out of it, you're paying to basically go backwards. So it makes it a moot point to go through and pay for things if we don't have all of those components able to be supported by the new controller. And this, once again, I've already covered with this particular client, but these are questions that come up all the time. Can I implement this? I need to have this. I want this switch feature. I want this feature on my new system. And once again, we can implement whatever you want, pending, of course, you understand it. If you don't understand it in terms of the hardware actually accepting that new feature with the new system, or you not understanding how to set everything up, which then, once again, we're getting into more variables with you understanding motion control software, understanding the limitations of CAM software, because I get questions all the time on how do I set up my system for such and such feed rate. Then we're getting into different training, and once again, the price keeps going up because then I'm implementing training. I'm not implementing actual system configuration building. So again, look at what you're asking. As we look at this, though, in terms of pictures, we still have a lot to learn here. We can see that they've got this in an enclosure. Once again, this system's from early 2000. We've got one central point of ground here. We've got crimp connectors used everywhere. The enclosure is filthy. And I see this on a lot of older systems. I've just discussed this in my previous video, that these machines should be kept immaculate. Number one, on top of just a common sense thing of keeping things clean, that it'll run better in terms of longevity and what I've discussed before as far as overall being more accurate in terms of the gears and everything else we're dealing with. But let's look at the facts that you're dealing with wood. Wood is flammable, and God forbid there was a spark, any wire comes loose, you're really enhancing the option for there to start a fire. So really it becomes way more serious when we see this level of dust, and you'll see this all the way through the machine. Okay, so again, guys, please pay close attention to that. This fan right here, I don't see any filter on this. I'm sure if it does have a filter, I don't know if it's been cleaned, but judging from the amount of debris inside this enclosure, this is not acceptable. So just, once again, we're just going to cover everything in brief detail. Scrolling down, for those of you who've never seen a Gerber Sabre 408, here's the chassis itself. You can see it's got the vacuum table. He's running a very large spindle. I believe it's 7 horsepower. So again, this is a serious piece of equipment. They do a lot of kitchen work with this machine. As we come down, we can see the old controller cabinet. And once again, these are really interesting to look at, and I think there's a lot to learn here because, again, older electronics, you can see, they really just did the old spiral wiring just to really mitigate noise. And again, in certain instances, that may be all that's required. Once again, all we're trying to do is drop it, the EMI down to a level where it should not interfere with the controller. However, in best practice today, I would never recommend just doing that. First of all, it's extremely time consuming. But second of all, it's just not going to be near as effective as double shielded cable properly grounded. Now, one thing I will say that we can all learn from what you're looking at here that I do love from the older systems, because I get asked it a lot, is there anything you really love from the older systems? And there's one thing I really do, and I haven't really discussed it, and many of you will appreciate this the more you work on your own system, is again, we don't have all the cable channeling that most systems have. So what does that mean to you? Well, I've discussed this before. You see guys using tons of cable channeling. You see large-scale manufacturers doing it. And the thing is this. When a large-scale manufacturer does it, they do it for the purpose that they're expecting you to hire a technician, their technician, to work on that actual system. But when you're working on it yourself, you would have to go in and go through all that cable channeling to access, per se, this particular plug if you had to get to it. With this wired this way, everything is easily accessible. So again, you can see mimicking of older systems. I pulled basically in my systems what I feel worked the best for me, for my clients, because serviceability in the field is optimal. You want to be able to switch a drive out immediately. You don't want to have downtime where you have to pull out the whole chassis cabinet and have accessibility issues getting to every wire and actual plug that you need to get to. So keep that in mind as far as what we're looking at here. I'm going to scroll down now, and you can see old controller cabinet 2. Again, we see everything going on here, and we've got everything over here. And you can see how intricate these are in terms of what we've got compared to an integrated drive system. Now, I did a video on those already, and when you judge between this picture coming over here and then this picture, you can definitely see how complex these systems were back in that time frame. So again, going from an integrated drive system in terms of that next level step up to modern technology is going to streamline this machine tremendously, and the client was aware of that. And the client is also anxious to get away from servo motors, and he had a servo motor fail on the system. The price is crazy, which I get told all the time for these older systems, and it just doesn't make sense for what they're doing. Again, we have the spindle and the Z-axis. Of course, here's the spindle, and of course here's the Z-axis. Now, on a Gerber system, what I want to point out, and again, there's stuff to learn here. So for my guys serious about doing retrofits, what you can see here is we have a collet that goes over the actual pulley system that actually engages the Z-axis. Now, these are very common on older systems, and the thing you have to realize with this is that if your bore on these pulleys do not match your motors in terms of them being too small, you're usually okay, because you can usually have enough meat left on the actual bore of the actual pulley to open it up to accept the new motor shaft. However, if it's too big, then you have to figure out how you're going to insert a collet to go inside there so that you can do it. I've seen guys do all kinds of options available, but again, very, very meticulous retrofit if you do not find the properly sized motors. In this particular instance, the client feels that he's already got an option available, so he'll be all set with that. Once again, on an older system, we have a lot of variables here. We have a lot of moving parts for this transmission. Okay, once again, you know why I love a ball screw. It's direct drive. What we have here is pulley to pulley, then we have the belt, then we have these collets, then we also have to make sure there's no play in the pulleys. So again, got a lot of moving parts here. Things need to be done accurately. We don't know how old the belt is. The client will go over that as well. You can see the spring tensioners here. This is unique to these systems and how everything is set up. So again, and we can look inside this pocket. We'll see this down as we scroll down, but you can see the machine has not been in use, it appears, for some time. It's got a lot of different debris all over the place. So we'll keep scrolling. Here's the spindle connector cable. I'm going to just zoom out a little bit so we can see what's going on. We'll zoom out a little more. Here we go. Again, typical NEMA L1620, nothing big here. It's three-phase. Once again, European Union. Spindle connector cable. And of course, and I want to point this out again, we can see here we have the actual connector going in. And again, due to the age of the cable and the time frame, these cables were not properly double shielded. I can tell you that already just from looking at it. And especially the diameter of it, you see no foil coming out. We see nothing. And no electronic company, would actually have a cable with a bare boot like that. So that's not common. Usually you'd see a stress relief here. And once again, this would be all secured properly with heat shrink so that this is a sealed application. This is interesting to see because, again, I get a lot of questions on older cables on, hey, I don't know if my machine cable is actually double shielded or shielded. Well, if your cables look like this, guys, forget about it. They should be replaced. Once again, newer technology, that's what we're looking at. You're looking at, stabilization of the machine. And this is something I expressed to this client, that not only am I here to go through, because he paid for a consultation, not only am I here to go through and discuss the new design of your new controller, but also I'm going to analyze the system in general of any weaknesses that naturally exist. Everything I'm going to bring to their attention, it's up to him if he decides to, go through the system and update everything, or he can do it at will. I mean, again, it's totally up to them, but the big thing here is with a retrofit of this caliber, every component that you do not retrofit at the time of the new controller leaves another possible variable to give you issues. And that's something you guys have to think about. And I say this to everybody because it's something that's majorly overlooked. They think just by buying a new controller, my problems are all gone. That's usually the case. But keep in mind, older hardware have different calibrations in terms of what it's going to do to the system as a whole. So when you think about it like that, there is the potential all the time that something that worked okay with an older system may not work okay with a newer system. It's just inherent of this genre. We're dealing with robotics, and you're working with a robot that may be 22 years old, 20 years old, and then you're giving it a new controller, but all the cables are outdated. So pay close attention to that. I have certain clients that say, hey, I don't want to spend on the cables now, but I want to buy the controller. And it's like, okay, but realize what you're doing. It's kind of like buying a new car and putting used tires on it. So it sounds as practical as that analogy, and that's the absolute truth. Once again, you have no idea what you're asking for when we use used components at that age calibration in comparison to new controllers of this modern age. So these are things to just keep in mind. Once again, we're in spindle VFD cabinet 1. And you can see here, we've got standard terminal block, nothing fancy, just a lot of wires going in. Once again, they labeled them to the best of their ability. It's always amazing to me, though, I have to say, how the proprietary systems are always done, and they usually only use 2 letters to label each actual connection, which I find amazing. I also find amazing you see a single point terminal block being used with 2 leads. We also see it over here and over here. This is definitely a safety hazard. I'm surprised they actually did that, especially in the European Union. I don't know if this system actually came from the States, went over there, but usually in the European Union, they actually have to be up to code, and these systems are checked and validated. So that's something that would definitely be looked at, and definitely a no-no. But it just always baffles me because on my systems, I always have to label everything. I'm not that good at always remembering. You do a system today, and then you got 3 more to do next week. You want to remember what you did on each system. And of course, if it's a standardized system, it's easy. But if it's not, and I'm doing custom controllers for clients, I label everything. This way it's easy for them, and it's easy for them to regurgitate to me, hey, Ben, this is what I'm having trouble with. And that's exactly what it should be done for. I'm just always baffled how I see older systems with 2-letter or 1 numerical. alphanumerical label on there, and they can actually decipher what that is. So again, we've got the Persky spindle. Again, nothing really crazy here. It's just a very large spindle. Now, he did send me the table suction VFD manual, and we did discuss, I'm going to just rotate this. We did discuss that if he wants PWM control of the system, that I would need the information from the manual to see about wiring in the PWM, because this is not a VFD I'm familiar with. The issue is that this is for suction control. Let me just scroll down here. This VFD is for suction control and not for the actual spindle. The one picture in the beginning, like I said, I would draw in to what this actually meant, is that if your system has multiple VFDs in use, this is where things get convoluted, is that the end user will purchase, typically, a used system. They have no familiarity with the components, and then they say, hey, I just want to change the controller, and they think just by changing the controller they're good to go. It's never that simple, guys. Every component in a system has to work in harmony. If it does not work in harmony, you have a paperweight, and it's a fact. And that's why I say doing this is, some of it is knowledge, yes, some of it is luck. And why I say it's luck is because it depends on how deep down the rabbit hole you want to go into conversion, if the motors fit, if everything lines up, how much spacing you're dealing with. I have certain clients that will have machines in-house that they can make the components they need if they're custom to do the retrofit, and then they're golden. I have other clients that'll pay me to have the parts made, and then they do the retrofit, and they're golden. The question is, how much resource do you have available? If that machine is going to make you more money and it's cheaper to do the retrofit and paying for custom parts, they're going to do it. But if you're a guy in your basement just starting out, that may not be the case. So be very, very careful. And that's why I say getting a consultation is always the best investment, because yes, you're going to pay, but you're going to pay a hell of a lot less than making $1,000, $2,000, $3,000, $4,000 mistake. That is, to me, smart. That's a smart investment. When you don't know, you ask someone that does. Because if you're going to take a guess, in this particular instance, he just sent me the wrong manual for the VFD included. And again, not such a big deal, but we know that I can't use this manual because it's certainly not going to be connected to the VFD. If he cannot get the VFD's information that I requested, and once again, this is the suction VFD, I'll rotate this. And as I was stating, if he cannot get the spindle's PWM wiring information as far as the terminal block, the connections, all that neat stuff, the programming of that specific VFD, then he's SOL. I mean, because once again, I am not going to take full responsibility on any system to know every configuration out there. There's no way I can do that. And again, there's no way any vendor can do that and shouldn't take responsibility, I feel, at all for that. These older systems, these are the hang-ups you have. If this hardware is older in any capacity, and you can definitely tell from the wear on this, these are older systems, they're not new, and these are the hang-ups you have. You don't want to replace things unnecessarily, but by the same token, if it's no longer supported or you have to hassle with support, and I tell you guys this all the time buying things overseas, if you think they're there just because they're going to sell you something and all of a sudden they're very responsive, you'll know the truth after the sale when you have a question if it's real. And that's what you're paying for, and that's something to think of with any vendor, myself or anybody else. Are they there, or are they going to disappear after a year? And I can't tell you how many people do, or how many vendors sell from overseas, and they're so responsive up until the point you guys have a question as an end user and you're screwed. In this particular instance, if he messages this company, are they going to respond with the required information? Do they have an actual engineer on staff that can actually walk him through it? If they don't, he's alone. Because remember this, if I build a controller to support the features, just because the port is on the controller and you can support it in the software, if you can't integrate the cable on your end and actually wire the system and actually program the VFD, guess what? It's useless. And that's why I say going through this, it's imperative to go through this and do it carefully. Here's something else I really want to cover, because I think this is a really, really great picture. And when I say that, it highlights what I've seen in a lot of shops. You can see the wire management here completely sucks. And when I say that, I say it in a facetious manner because I realize that I know the system hasn't been used. Not in a while. We could see the dust buildup is ridiculous. There's a suction system. But with wire management like this, guys, you once again have an immense fire hazard. Number one. Number two, all of this should be cleaned up, everything. And when I say that, the wires should be made nice and neat. Everything should be nice and clean. Again, we want to make sure in the event that there is a problem with the system, you're able to troubleshoot it as quick as possible. The faster you can troubleshoot using T&E, the faster you're going to have your machine back up and running. Now remember, I said it earlier, this client, you can tell just by looking at the system, this is a client that's running a company. He's actually doing kitchens and remodeling. This is going to be a business system. It's imperative to have this machine in a mil-spec format, so to speak, to where everything is neat, everything is set, so if there is a problem, he can isolate it as quick as possible. This is something I cover in most consultations, and that's why I always request pictures, because it sounds obvious, but it's something that's seldom done. And it's funny because the clients that actually do go through and do it, they usually never need to be told to do it. They'll just do it because that's what they do. And, you know, I learned so many things from clients watching how they do wire management, watching how they, you know, handle their equipment, how clean is everything. I've discussed that before. Looking at this, if he had a trouble with a cable, how would you figure out what cable is what? How would you figure, I mean, how much time are you losing? So, again, think about that. It's not just a neatness thing as far as how clean it looks, but it's going to make your life a hell of a lot easier going through and troubleshooting something should something come up. And remember, this system hasn't been run in quite some time, so we want to make it as easy as possible to have this system automated and also be able to identify any issues right out of the gate. This way we can get them off to the races making money. So coming over here, we've got our X-axis mount and belt. Again, we can see how dirty this is, but we can see the pulley system, and here's our tensioner. And again, we come over here, let me zoom in a little bit, and we can definitely see that actual collet within the actual collet here within the actual lock collar. And that lock collar, you can see, goes over the motor shaft, but this is actually separated. It's got little cuts inside that collar so that it can naturally pinch on the motor shaft. Once again, we also have then the pulley, and that goes to the belt. And once again, we can see how dirty this is. And this is stuff that I've discussed, once again, previous video, I think even this last week, how dirty systems really are affected by this. And you can see all the dust, debris. I'm sure he's going to go through and clean all this prior to the new system install. But these are things definitely to look at. One thing that's unique about Gerber's is you can see the motor mounting plate here, and you can see how the holes are cut, so you can actually space the motor properly to give you proper engagement on the belt. Very, very unique, very interesting. Keep going. Y-axis motor. Okay, and she's underneath. Now this unit is, aside from how large she is, she's only using a single motor on the Y-axis because it runs an actual drive all the way through the table. You can see where the pulley system would be in here, motors mounted here, and then that drive pulley system just goes right down the center of the table. So it's not using a typical slave configuration, even though the table is extremely wide for that platform. But again, it works well. I've done many retrofits, and it is possible to do, especially when it comes from the factory. I have a lot of guys that want to do it to get away from a slave axis, so it's less complicated. The thing you have to realize is if you're doing it yourself and you want to retrofit a machine to incorporate that, you have to make sure that that drive is dead center down the chassis, or you will have the potential for an imbalance that will cause racking. So everything must be balanced, so to speak, in order to give that transmission that balance it requires for smooth automation. So everything we have here looks about as what you'd expect from early 2000. Once again, nothing here is shielded. You can see your cables, everything. It's pretty much open. These are just laying on the ground. Y-axis mount and belt. And there you go. There's a transmission for the Y-axis. So you can see here's the actual center drive going down the actual Y-axis. Once again, same pressure collet. We've got there, everything mounts the same. That's why these chassis are pretty basic as far as the retrofit. Once again, you do have the motor spacing plate, which I think they did a really good job on if they're going to go this route as far as using a pulley system. Once again, you guys all know how I feel about that. You can definitely see the amount of debris in here. Keep going. Z-axis motor. Now once again, I'll zoom out of here a little bit. I don't know what these extra bolts are for, but we want to clean all this up. And again, these are old servo motors, so you can definitely see the size there and the plugs and all this. And this will be a much neater system once the new motors are installed. Z-axis motor, or excuse me, Z-axis mounting belt. Once again, you can see all of the tensioners on these. These should be serviced all the time as well, and something I really haven't discussed, but you always want to go over these springs, make sure the tension is proper, make sure your engagement's good, and I would do that easily. My magic number is 10 hours of use. In commercial environment, probably be more closer to 7 hours of use. Check everything. And the reason I say that in a commercial environment, it's always a little tighter as far as maintenance hours, is because you already know the machine's going to be used indefinitely. Now, right now, they're not using this machine at all, but if it goes 8-10 hour days, you definitely want to make sure after every shift go over everything. I would schedule a PM in the next morning, and in this way you can go over everything, make sure you're good, do your checklist, and you're set. Once you've created the checklist, make it autonomous in the fact that your end user will actually print out that checklist like a pre-flight checklist in the morning the following day. If it's a normal work day, he'll go over and service the equipment, at least leaving comments to what he finds. This way, there's no surprises, and once again, we can eliminate downtime due to the fact that we're going in excessive time for PMs. And once again, guys, for the novices out there, when I'm saying PM, I'm actually discussing preventative maintenance, okay? And regardless of, and I've said this prior, regardless of what system you're using, preventative maintenance is everything. It's the only way you're going to learn your system. So again, we can see here we're at the end of the pictures right now. They cost you 26 minutes for me to do this, and you guys can see exactly what we're working with, and that's why I was so grateful that this client sent me these pictures in this much detail, because these are great pictures. We can learn a lot from them. You guys can take away from them. And when you guys are out there thinking about doing retrofits on older systems, by all means, take your time, analyze what you're looking at, and keep in mind, the older the system is, and the dirtier it is, and the electronics are old, don't be so scared about how filthy the system is, because naturally it can all be cleaned up if you're willing to invest the time. The big thing here is that you're going to go through and understand the amount of electronics that need to be replaced and the mechanics of the system, which need to be calibrated and correlated to the new motors you're purchasing with that new controller, regardless of who it's from. So after you get that all taken care of, then we have to get you to learn the new motion control software and also be comfortable with it, the whole workflow process from your CAM to your actual motion control software, and then once again to go into the actual product creation. But the main thing here is understanding that a controller retrofit does not begin with the controller. It really begins with the mechanics of the machine. The mechanics of the machine naturally can support the new motors. The controller retrofit is very, very quick. I mean, but I get a lot of guys that don't even take measurements on the bores of their pulleys in this instance, or whatever drive system they have, and then they're shocked. They're like, oh man, I need to change my motor mounts because now I don't have clearance. It's like, yep. And I need to worry about my motor couplers because now I don't have clearance there. They may be rubbing into the chassis, yep. Or maybe rubbing into the motor chassis. That's a possibility as well. So these are variables we have to look at. You know, scrapping the electronics is always an easy thing. It's actually going through and analyzing the system on what we can do to salvage what's usable, and then of course what's not salvageable. And then of course, because I know many of you are already going to say it, I hope you're going to say it in the comment section, is that you only notice one central ground point on the whole system, or at least I did, which was right here. There was no grounding done on the entire chassis, and that was something I brought up to the client as well. I always address to my clients, is your chassis grounded? It's probably one of the most basic questions as far as electronics go, and yet it's something that I will never understand why most clients do not ground the chassis. If I bring it up or if they ask about it, it's usually then addressed, but up until that point, it's not. And without grounding the chassis, you're really never dissipating any potential EMI, regardless of even if you're using double shielded cables. So these are things, once again, to think about, guys. Really think about it. I hope that I've made you do some thinking if you are looking at doing a retrofit, because again, there's always something to learn from these videos. And once again, if you do want to contact me, please do reach out to me direct at storm2313@gmail.com. You can also message me direct through my eBay store, eDealers Direct. You'll see links in the beginning of the video and at the end. I thank all my subscribers for listening to this 30-minute actual review. Take care.